Hey guys, it's Adamo from BBT. So in this question, we'll be taking a look at the continuity of limits. So this question, what's important to note is that continuity is nothing more than a hole in the function. Is there a break in my graph? You guys are used to seeing functions like linear, quadratic, inverse, exponential that don't have holes or breaks in them. However, in the topic of limits, sometimes you will encounter breaks or holes in the function. And what this is here is a piecewise function that shows different parts of this g of x equation where we have to note or see essentially if the function is continuous throughout. So if there's no hole or no break throughout the function. Well, how do we evaluate this? I'm going to show you a very simple way to do it. We are not, which is important, I'm going to stress, we are not looking for whether the function is removable or non-removable discontinuity. All we're doing in this question is answering whether it is continuous or discontinuous. So I'll show you the steps as to how to solve this question. So the first thing we have to do is essentially note that, look at the middle part. It says that g of x is essentially continuous at x equals 2. That's a very important point to note. So let's keep that in mind. The second thing we'll look at is we have to evaluate the limit from the left-hand side, but we must also evaluate the limit from the right-hand side. What did we do here? This is the limit evaluated at point 2. So at that point from the middle. Now we have to evaluate from the left and from the right. So I'm going to evaluate this g of x from the left. So g of x, essentially from the left, what I'm going to say is the limit as x approaches 2 from the left-hand side. It's not negative 2, remember, it's from the left-hand side of what? So we have to come up here and say, is it this one or is it that one? Well, from the left-hand side will not be greater than 2. It'll obviously be less than 2. So we choose this one. So that's where we plug this in. Okay? And all we do now is plug in our limit. So what do we get? We will get 1. 2 squared over 4 is 1. So already we can see that there will probably be an issue. But let's continue and get the limit as x approaches 2. So make sure to write this down. From the positive side of what? Well, what's left is the 5 minus x cubed over 2. You notice this says when x is greater than 2. So 5 minus x cubed over 2. So just plug in your limit and you get 2 cubed, which is 8, over 2, which is 4, 5 minus 4, 1. So essentially we're ready to conclude. So let me show you how to conclude. And this is probably like the most important part that a lot of students kind of mess up on. Because you guys will do all the work right, but then you'll have sometimes the wrong conclusion. And you'll lose a mark or two on a test or on an assignment, which can make the difference between, the mark that you want and one that you don't. So our conclusion here is this. The limit as x approaches 2 from the negative side, right, is equal to the limit as x approaches 2 from the positive side, right? 1 and 1. However, that, or these two I should say, are not equal to the limit as x approaches 2 at that point. Because if you look, this answer is 2, and whereas these two are 1. Therefore, in order for a function to be continuous throughout, they must yield the same answer from the left, from the right, and at that point. So I'll repeat that. This is all you need to know for continuity at this level. For a function to be continuous throughout, the limit must be the same from the left, from the right, and at that point. However, here we notice that from the left is the same as from the right, but not at that point. Therefore, the conclusion is g of x is essentially discontinuous. Discontinuous. At which point? We have to mention that. At x equals 2. And you are done. So, remember that this question is only half the battle. Because I didn't ask you guys if the function says that if it's discontinuous, whether it's removable or non-removable. I'll leave that topic for another question. But in this question, to recap, all we wanted to see is if a function is continuous or discontinuous throughout. Remember, for it to be continuous throughout, it has to yield the same answer from the left, from the right, and at that point. If it does not, your function is discontinuous at the point that you will be outlined, or at the point C here, which is 2. Alright guys, so I hope I helped for continuity of limits. Be sure to check out more of our videos, or sign up online for one-on-one tutorials if you're interested. Alright guys, remember that there's crash courses as well for December and April if you guys are interested.